Here we are Group 8, going to present you some answers to some of the important questions of plane table surveying. The first question is, what are the different components of the plane table, and we have to mention its use. First component is plane table, alided, spirit level, compass, U-fork or plumbing fork with plumb bob, chain or tape. First component is plane table. It's a drawing board of 750mm into 600mm size made of well-seasoned wood. The top surface is well leveled and the bottom surface consists of a threaded circular plate for fixing the table as the tripod stand by a wing nut. The plane table is meant for fixing a drawing sheet over it. The positions of the objects are located on this sheet by drawing rays and plotting to any suitable scale. Next comes alided. Plain alided. It consists of a metal or wooden ruler of length about 50 cm. One of its edges is beveled and it is known as the fiducial edge. It consists of two vanes at both ends which are hinged with the ruler. First, there are two kinds of vanes. First one is object vane, carries a horsehair, and a side vane provided with a narrow sill. The next one is telescopic aid. Heavy metal rule to which a frame is attached. This frame supports the telescope, providing a very accurate line of sight. A spirit level on the rule helps to level the table. It can also take inclined line of sight to objects low or high. Next one is spirit level. The spirit level is meant for leveling the plane table. It is a small tube containing a small bubble of spirit. The bubble is visible on the top along a graduated glass tube. The next comes the compass. Trough compass. It is a rectangular box made up of a non-magnetic metal containing a magnetic needle pivoted at the center. It consists of a O mark at both ends to locate the north and south direction. The next component is the U-fork or plumbing fork that is attached with a plumb bob. The U-fork is a metal strip bent in the shape of a U hairpin having equal arm lengths. Top arm is pointed and the bottom arc carries a hook for suspending the plumb bob. Plumbing fork is kept on the plane table, the vertical line of a plumb bob that passes through the point edge of the upper arm. The plumb bob helps in transferring the ground point to the drawing sheet and vice versa.
Explain the operational procedure of plane table survey. After fixing the plane table to the tripod stand, following steps have to be done. First, fixing the table on the tripod stand. Second, leveling the table. Third, centering the table. Fourth, marking the north line, and then orientation. Fixing the table on the tripod stand. The tripod stand is placed over the required station with its legs well apart. Then the table is fixed on it by a wing nut at the bottom. Leveling the table. The table is leveled by placing the spirit level at different corners and the various positions on the table. The bubble is brought to the center of its run at every positions of the table by adjusting the legs. Centering the table. The drawing sheet is fixed on the table. A suitable point P is selected on the sheet to represent the station P on the ground. A pin is then fixed on this selected point. The upper pointed end of the U-fork is made in contact with the station pin, and the plumb bob, which is suspended from the hook at the lower end, is brought just over the station P by turning the table clockwise or anti-clockwise or slightly adjusting the legs. This operation is called centering. The table is then clamped. Care should be taken not to disturb the leveling. Marking the north line. The trough compass is placed on the right-hand top corner with its north end approximately towards the north. Then the compass is turned clockwise or anti-clockwise so that the needle coincides exactly with the 00 mark. Now a line representing the north line is drawn through the edge of the compass. It should be ensured that the table is not turned. Orientation. It is necessary when plane table survey is conducted by connecting several stations. The orientation must be performed at every successive station. The process of keeping the plane table at each of the successive stations parallel to the position which is occupied at the first station is known as orientation. The orientation is done by a magnetic needle or by the backsighting method. The back-sighting process is always preferred because it is reliable. During orientation, it should always be remembered that the requirements of centering, leveling, and orientation must be satisfied simultaneously.
Radiation method. In the radiation method of plane table surveying, the direction of the objects or points to be located are obtained by drawing radial lines along fiducial edge of alidade after getting the objects or points bisected along the line of sight of the alidade. This method is suitable for locating the objects from a single station. In this method, rays are drawn from the station to the objects and the distances from the station to the objects are measured and plotted to any suitable scale along the respective rays. And this is the procedure of radiation method. Suppose P is a station on the ground from where the objects A, B, C and D are visible. The plane table is set up over the station P. A drawing sheet is fixed on the table which is labeled and centered. A point P is selected on the sheet to represent the station P. The north line is marked on the right-hand top corner of the sheet with throw compass or circular box compass. With the alidade touching P, the ranging rods at A, B, C and D are bisected with rays drawn. The distances PA, PB, PC and PD are measured and plotted to any suitable scale to obtain the points A, B, C and D, representing the objects A, B, C and D on paper. This is the diagram of radiation method.
Now we move on to the 3-point problem in plane table. In this problem, 3 well-defined points are selected whose positions have already been plotted on the map. Then, by perfectly bisecting these 3 well-defined points, a new station is established at the required position. No auxiliary station is required in order to solve this problem. The table is directly placed at the required position and the problem may be solved by 3 methods: the graphical or Bessel's method, the mechanical or tracing paper method, the trial and error or Lemon's method. Today we'll be discussing the graphical method or Bessel's method. This is the illustration for Bessel's method which we'll be referring to during the procedure. Now coming to the procedure, in the first point, A, B, C stations are 3 well-defined points which have been plotted as A, B, C. It is required to locate a station at P. The table is then placed at the required station P and leveled. The alidade is placed along the line CA and the point A is bisected. The table A is then clamped. With the alidade centered on C, the point B is bisected and a ray is drawn. This is shown in figure A. Again, the alidade is placed along the line AC and point C is bisected and the table is clamped. With the alidade touching the position A, the point B is bisected and a ray is drawn. Let this ray intersect the previous ray at a point called D, which is shown in figure B. The alidade is now placed along the line DB and the point B is bisected. At this position, the table is now perfectly oriented and the rays AA, BB and CC are drawn. These rays must meet at point P, which is the required point. The point is then transferred to the ground by using a U-fork and a plumb bob.
Now we come to the 2-point problem. The 2-point problem can be stated as to find the position A on the table of the station occupied by the table. Given the accurately plotted positions P and Q of 2 stations P and Q, visible from the instrument station and by not occupying these 2 stations. Here is the diagram showing the 2-point problem. Now move on to procedure. Plot the points P and Q to well-defined points whose positions are plotted on map as P and Q. An auxiliary section B is selected at a suitable position. The table is set up at B and leveled and oriented by I position. It is then clamped. Touching the alidade P and Q, the points P and Q are bisected, and rays are drawn. The rays will bisect at B. Alidade is centered on B and ranging rod A is bisected, and a ray is shown. A point A1 is marked on the ray. Shift the table and center on A with A1 just over A. It is leveled and oriented by backsighting. Keep the alidade touching the point P. The point P is bisected and a ray is drawn. The ray intersects line BA1 at point A1, which was assumed before. Keep the alidade on A1. The point Q is bisected and a ray is drawn. The ray intersects BQ at Q1. A triangle is formed. PQQ1 is the error triangle which should be eliminated. The alidade is then placed along the line PQ1 and a ranging rod R is fixed at some distance from the table. Alidade is placed along the line PQ and the table is turned to bisect R. The table is said to be perfectly oriented. Finally, the alidade centered on P and Q. The points P and Q are bisected and rays are drawn. The rays intersect at a point A. This would represent the exact position of the required station A. Station A is the marked on the ground